For some time now, Logic has made it possible to both change the project tempo and conform audio regions to the new tempo, or employ beat mapping to instead match the project tempo to the varying tempo of a particular audio recording. Smart Tempo changes the way this can be done, simplifying the process and adding additional capabilities. But for the most part, Logic's previous time handling features are also still present in the program. People who've been working with Logic for a long time will probably already be familiar with them, but for those new to it, it's worth a brief look at them to put Smart Tempo in better context. Naturally, anytime the playback of audio recordings has to be changed to match changes in the project tempo, behind-the-scenes Logic's flex time processing is used to accomplish this without unwanted pitch change or tonal artifact. This is the case both for Smart Tempo and for Logic's older options. Before Smart Tempo took on the task of automating much of the work of matching or conforming audio to project tempo, users could still do this by hand. Flex time would be manually enabled, and then audio regions could be stretched or squeezed by hand. With the optimal flex mode selected, the audio region would then be in time with the changed project tempo. For somewhat more automatic operation, a parameter in the region inspector could be enabled to make audio regions follow project tempo, though there were a number of limitations. But all of this had to be after the original audio was already recorded, either with or without a click. These options are still possible, in some cases somewhat expanded, as we'll see. And ideally, Smart Tempo should make the task of conforming audio to tempo more automatic, with much less manual attention required. As for beat mapping, depending on the specific Smart Tempo mode in use, this can also be an automatic process, but once again the older methods are still available as well. To make the project tempo match the tempo of an audio file, or any region for that matter, in previous versions of Logic, there were a couple of approaches. A command called Adjust Tempo using region length and locators could be used. The way it works is the user creates a cycle area of a specific number of bars, and then selects a region of the exact same length, the exact same number of bars. Since the region will assumedly be at a different tempo than the project tempo, the length of the selected region will be longer or shorter than the cycle area. That region will then be used as the reference for the new project tempo. When the command is invoked, Logic will calculate the correct project tempo to make the cycle length match the region length in time. You'll have the option of making that change just for the selected area or for the entire song. When a more precise tempo map is needed, as with audio recordings at variant tempo, then Logic's global beat mapping track can be used. When a MIDI region is selected as the new tempo reference, the beat mapping track in the global tracks area will display the notes in that region under the existing bar and beat lines. With audio regions, the underlying audio file must first be analyzed and have its transients detected, but in either case, the bar and beat lines can then be dragged to the matching notes or transients in the regions, and Logic will calculate the new tempo map. This has to be done from beginning to end for it to work properly, and it can be fairly tedious and time-consuming with recordings that have a lot of subtle tempo variation. Plus, the accuracy of the beat mapping is dependent on the care taken by the user to precisely match up the bar and beat lines with the actual musical material. The beat mapping track does offer an option for automatic beat mapping. You can choose the maximum number of tempo events and optimize the analysis for particular musical performances, like ones with gaps, for instance. And then Logic will attempt to perform the beat mapping on its own. Of course, you can still go in later and tweak the results if necessary, and in my experience, that was necessary more often than not. From what I've seen so far, Smart Tempo's automatic algorithms seem to be improved, more likely to come up with accurate results when automatically detecting and mapping tempo. So why are the older tempo handling methods still available? Well, to maintain compatibility with older projects that use them would be the main reason, but there may still be specific situations where a feature of one of the older tools is needed for something that Smart Tempo doesn't do, or at least doesn't do yet. And with that little bit of background covered, let's start looking at Smart Tempo. I'll begin with the basic Smart Tempo modes in the next video.